Hey, welcome to this video. In here, I'm going to walk through normal curve and sampling distributions review for AP Stats. This is our 7th review session for your AP exam in May, which is approaching soon. So let's jump right in. The normal distribution and sampling distributions. And by the way, this mainly covers the contents from Unit 1 and Unit 5, but since this content is just so important that it will show up almost everywhere in different units, so it's just good to know all of the details related to it. So first of all, the normal curve. Represented using notations is like this: a big N with parentheses, mu, and standard deviation inside. So mu in here means mean, and standard deviation just this symbol data. Inflection points, this is where you use x bar plus or minus the standard deviation. And the empirical rule is 68, 95, and 99.7%. So 68 means you are 1 standard deviation away from mean, and 95 means you're 2 standard deviation from mean, and 99.7% is 3 standard deviations from the mean. And this is a visualization of how does it really looks like on a normal curve. A z-score is z equal to x minus mu divided by standard deviation. Also, be able to use z-table and TI-84 calculator to help you draw the normal curve and figure out the standard deviation or the mean. Or like the x values labeled on this horizontal line. Check for normality, there are 3 ways. First is using histogram or box plot. So for example, here is, this is not a histogram or box plot, this is a stem plot, but it also can kind of show you is the distribution normal or not. So in here we can say, well, it's approximately normal. And a second way is using empirical rule. So just like I said before, 68, 95, and 99.7% all corresponds with 1 standard deviation, 2 standard deviation, and 3 standard deviation accordingly. And if we just use this data right here for our example, just take a moment, like pause this video and type all of this data into a calculator. Okay, I hope you finished typing. And after you did all of that, please make sure you know how to find, for example, if I ask you to find, well, what is the middle 68% values lie between, you should be able to tell me that it is between 48.6 and 61, which is around 74% of the data. So we expect, our prediction is the middle 1 standard deviation away from the mean. That range should be 68% of the whole data. But in reality, for this data set, we only got 74%. And same thing as 95% as our expectation, but we only got 93%. And this we got 100%. So we cannot say this is exactly normal, but we can say that it's approximately normal. So normal-ish. And third way is to use normal probability plot to draw a kind of give you a shape of the data. How does it look like to plot it on a normal probability plot? So the more linear it is, the more normal the data set is. And moving on to sampling distributions for means, proportions, and slopes. So for means, this is basically the content from Unit 5, and proportions is mainly from Unit 7 inference, and slopes is Unit 8 stuff. So you can see why I say at the beginning of this video that sampling distribution is extremely important, because it just show up everywhere. And I bet there definitely will be a bunch of multiple choice questions and free response questions asking you something related to sampling distributions. And let's go over some key vocabularies first. Sample means subset of the population you're examining. Population means overall group interested in. Statistics. Here are a couple notations for statistics, which basically means the sample. So when you're doing a sampling distribution, the x bar means the mean for sampling distribution, s means the standard deviation for the sampling distribution, and p hat means the proportion for sampling distribution, and beta, it just means, I bet it's slope, right? It's a linear slope. Yeah, it's all Unit 8 stuff. So yeah, you can feel free to check my video for that in my playlist. Parameter, those are all the corresponding notations for population. And means, here is a rough drawing for what does a sampling distribution for means looks like. So in the middle, the sampling distribution mean is the same thing as the mean for population, but the difference is this normal curve just made up by a bunch of x bars, so a bunch of sampling means, and the standard deviation means is the standard deviation of the population divided by the sample size, the square root of the sample size. And if n is greater than 30 or the population is normal, then we can say that the sampling distribution is normal. A central limit theorem is larger n means more normal and sampling distribution will be. So basically, the more sample size, like the more sampling distributions you get, and you group them together to create this normal curve, the more n's you get, the more normal this curve will be. Proportion, same thing. The mean is the same as the population's, not the proportion. The proportion is the same as the population's proportion, and it's made up by a bunch of p hat. Also, the standard deviation is the square root of pq divided by n. Q is 1 minus p. And you have to make sure that np is greater than 10 and nq is greater than 10. All of those, there are 3 conditions, and the only difference between means and proportions is the third one. So the previous 2s are all the same. So the first one is simple random sample, and the second one is the sample size should be larger than 10% of the population. Also the slopes, yeah, and beta is the kind of, you can think of it as the central or the mean proportion, but it's the same thing as the population's beta, and it's made up by a bunch of lowercase b's, and the standard deviation is, make sure you use this notation like sub b right next to this SE to represent the standard deviation for the slopes. And we cannot use any formulas to directly calculate the SE sub b. However, we can use this relationship, which is t equal to b over SE sub b, and arrange this formula a little bit. You can calculate what the standard deviation or the standard error for b it is. Okay, and that's all for this video. And also, this is our last review session for AP Statistics in May for 2026. I hope you enjoy all of those videos and learned something about it. Like, the purpose of those videos is just help you to quickly review all of those vocabs, or just go over them again in your head and reminds you, well, what should I look at? What should I pay attention to? So anyway, I hope you learned something from it. Thank you so much for watching, and good luck on your AP exam.